Now we want to talk about sorting. What is sorting? Sorting means let's take a deck of cards which is not in the correct order. Let's say we have this deck of cards and now let's bring it to the sorted order. How would we do that? Now I will sort. Please watch, find out what strategy do I follow. Okay, what was my strategy? My strategy was selection sort, a very intuitive strategy. What did I do? If I have a deck of cards, I go through all cards and find out what is the one with the smallest value. Then I have 7 remaining cards. I will find out what is the smallest value. This one. Go through the deck, smallest value, go through the deck, smallest value, and continue the job in that way. That is selection sort. But there is more than one strategy, and I also want to show you in detail the other algorithms. Let's talk about insertion sort. Insertion sort means that I start with one card and then I have a new card, and now I find out what is the correct position for this new card. Is it here or is it here? In this case, it's here. Let's take the next card. What is the correct position? This position. 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 What is the correct position? And this position. What is the correct position? And it's the last position. That is insertion sort. Okay, but there are more ideas which are possible. And quicksort, the basic idea of quicksort is do pre-sorting. Maybe I have the idea, let's place all cards highest 10 to the left side and all cards above 10 to the right side. So this way. And now I have pre-sorted. Here we have 3 cards, here we have 5 cards, and now we order these 3 cards, and then we order these 5 cards, and then I put the 2 decks together, and I have a sorted version of my 8 cards. But what is the strategy to do the job here? The idea of quicksort is do that recursively, and the idea of quicksort is do that in a very smart way. We will talk about that in an extra video. Now let's talk about merge sort. What is the idea of merge sort? Here, if we have this deck of cards, then the idea is, let's say we have an assistant. Let's divide the deck of cards in 2 parts. Let's sort this deck, let's sort that deck, and after that merge. So how do I sort this deck? By merge sort again, but in this case, okay, this is the sorted version. And how do I sort that deck of cards? Again with merge sort. This will be the solution in the end. And now let's go through the deck and merge. Compare these 2 cards. This one, a smaller one. Compare these 2 cards. This one. Compare these 2 cards. 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 This deck is empty. Now take all the cards remaining here. In this case, it's only 1 card, but maybe next time it's 5 cards. And then take that deck as a whole and put it to the right. And now we have a sorted version of our deck. That is merge sort. And we will talk about merge sort in detail later in an extra video. And now let's illustrate a little bubble sort. What is the idea of bubble sort? Bubble sort is a very primitive idea. Let's compare these two cards, correct order. Let's compare these two cards, correct order. Let's compare these two cards, not correct order. So swap. Compare these two cards. No, not correct. So swap. Compare these two, swap. Compare these two, swap. Compare these two, swap. Now this card is in the correct position because it's the largest element. We will find it sometime in the run through the cards, and it will be at the last position. Now go from the right to the left. Incorrect position, correct position, incorrect position, incorrect position, incorrect position, incorrect position. And now this card and this card we will never need to touch. They are the two elements which are in correct place. And let's again check correct order. Now go from the right to the left. Correct, correct, incorrect, incorrect. Okay. And go from the left to the right. Correct. Go from the right to the left. Correct order, correct order. We went through the whole remaining deck. There was not a single swap. So all elements are in the correct position. And that is bubble sort. So what is to say about quick sort? These are the 5 ideas. And why do we talk about sorting in a script about numerics? Sorting is not numerics, but sorting is part of a lecture, efficient algorithms, and I have chosen to be that also part of my lecture about numerics because it plants one idea in your head you will never forget. If you have a problem, then sometimes there is a very intuitive way to solve the problem. And normal people stop then and say, okay, I have solved my problem. I have an algorithm which will always do the job, and then they think the job is done. But sometimes the intuitive idea is not the best idea. And so it's a big benefit not stopping, but thinking about alternatives. And sometimes they are much, much better, but you can't know from the beginning what is the best one. You have to analyze these 5 algorithms, and when analyzing, then you will find out that this algorithm will perform much, much better. As long as we talk about 8 cards, it doesn't matter which one you use. But if we talk about sorting an array of 2000 cards, then the time consumed by the algorithms will be very, very different. And then you will see these algorithms will perform much, much better than these. And if you do the job for 1 million entries, then you will wait half a year for the answer. But in this case, you will wait only some few seconds or some few minutes. And when we later talk about numerics, then you will also see that having a problem, we talk about several alternatives solving that problem. And here I want to give you the reason why it's worth not stopping when you found one algorithm. What will be our following videos? The next video will be about selection sort. We will talk about the algorithm, how it looks like in MATLAB, in Octave. Then we will talk about bubble sort. The next video will about merge sort, and our 4th video will be about quicksort. And after that, we will compare how they compete. We will not do that by analyzing mathematically. We will do that by running the code for a large array, let's say 100,000 elements, and then we can stop the time, how much time uses which algorithm. Okay, here is my chapter in the script, but now I want to show you Wikipedia to the topic sorting, and I want to show you there are several algorithms. There's quicksort, there's merge sort. We will talk about that. There is insertion sort and there is selection sort. There are a lot more algorithms. We don't want to talk about every variant here. And there are even more algorithms and even more algorithms. If you are interested, feel free to check Wikipedia, and then you can see there are a lot of different algorithms.